Okay, so hello everybody. My name is Sara Gutiérrez and I am the Automotive Business Unit Director at GMV. So, yeah, you might be wondering what a company such as GMV, okay, we are highly present in space market, in defense, is doing in an automotive event. Okay, I will try to shed some light along the next 30 minutes. Automotive market is going through a huge transformation in the past years, and at the core of this transformation is the concept of a software-defined vehicle, which is a vehicle whose features and functionalities are, of course, defined or driven by software. And this is having a very big impact on the way OEMs operate and do things. So my intention today is threefold. First of all, I would like to highlight how expertise in technologies in other areas, for example, space, defense, can really be used as drivers of innovation also in automated driving and in the automotive market in general. Then I will also share with you some lessons that we have learned along this way of transferring technology from these markets, for example, into automotive, because this is not a plug-and-play process. And finally, I will share with you some real-world examples or products that we are currently offering and have deployed in automotive in this sense. So let's start. Let me say a few words, first of all, about my company, which is GMV. So GMV is a Spanish multinational which was founded in 1984. So last year we were celebrating our 40th anniversary, and our roots are tied to the space sector. Along these 40 years, there has been a continuous growth, and it has always been leveraged on technology, on the expert knowledge that we have built in certain technological areas in order to bring them to other markets. Today, we are more than 3,500 people, and we operate in several markets. For example, the ones you can see here, including, of course, space, aviation, cybersecurity, ITS, and for sure, automotive. Now, focusing on automotive, as we all know, we can really get different level 2 plus, or level 3 automated driving functions, which are already offered by different brands. Or we can also think of some level 4 use cases, such as the one of the robotaxis. And as we are progressing towards higher levels of automation, we have to face and overcome different obstacles and difficulties of very different nature. They can be regulatory, they have to do with technology, of course, with the methodological approaches that we have to follow, or, of course, related with the acceptance of the user and of the public. And it's sure that there are different efforts and initiatives which are already done in each of these areas. For example, there are different regulatory and legislation initiatives in different geographies. Huge investments have already been made in technology, but we need to go on in order to progress towards higher levels of autonomy. In terms of methodologies, many people have already mentioned today that, for example, in the case of validation, it is not enough really to follow the traditional methods consisting only on driving kilometers and thousands of kilometers, but we need to combine that with other approaches which take into account simulation, mathematical analysis, and some others. And of course, all this only makes sense if we put the user at the center of it. We need to answer many different questions. For example, when and where is it possible to activate automated driving functions? That is referring to the ODDs. In case of an accident, who is liable for that? Or how can we make sure that a system is safe if we are making use of sensors which are subject to errors, or a system is based on artificial intelligence? How can we be sure that we are covering all the different corner cases? How much safe is enough? Is it enough if we come up with a system which is 10,000, 1,000,000 times safer than human driver? And this is representing different domains that we have to take into account when we think of the automotive sector at present and autonomous driving. So there are different domains, and during this presentation, I would like to focus mainly on 4 of them because they will allow me to show what I want to share with you today. So ADAS and autonomous driving and the big importance of software at the core of it, because as we are really incorporating new automated driving functions, the demands for software and the complexity of it is really increasing. Then, of course, safety is something that is going to be increasing in terms of requirements, in terms of demand. Then the concept of the software-defined vehicle that I have mentioned before is really having different impact in the way that things are done, in the sense that traditionally we have thought about closed approaches where, once we get to the SOP, I mean, the product is there. However, with the concept of the SDV, there's kind of flexibility, which really allows us to go for further updates of the software over the air, allowing to correct different errors or really to add, fine-tune, modifying different features of the vehicle. And also, this evolution towards this paradigm of software-defined is really involving convergence towards more centralized architectures, which are rather convergent with the IT world. And these also have different implications. So increased complexity of software, of course. There are also increased connectivity that involves increased attack surfaces. And also, in terms of cybersecurity, the physical isolation, which traditionally existed in distributed architectures, is not going to be there anymore. So we have to provide different and sophisticated cybersecurity mechanisms in order to protect the new vehicle concepts and also, of course, make them more robust. So let's focus now on the autonomous driving and ADAS. So this is the typical AD block diagram, where we are very familiar, of course, with the perception stage, where different sensors, including cameras, radar, lidar, are performing the situational awareness of the surroundings. And this information is also fused with the GNSS information in order to provide localization. All this information is provided to a driving planner where the different information pieces are processed and the different maneuvers are defined and offered to the actuation stage, where we are going to act on the longitudinal and lateral controls of the vehicles. So we are speaking a lot about radar, about cameras and some other sensors, but I would like to highlight now the role of GNSS as the unique technology which allows for absolute positioning of the vehicle. And I would like to refer to it because traditionally this has been a technology thought for navigation purposes, but it can have a real interesting contribution for autonomous driving. So in this sense, it is used in a complementary way to the other sensors, allowing to recalibrate and reinitialize them faster, also adding redundancy. So in this sense, it is contributing to the safety case, and it can do it in different environmental conditions and in different kinds of environment, and in a very cost-effective way, in fact. But all this is possible if we are referring to high precision and safe or reliable positioning. So, as I mentioned before, GMV is a company which has been very close to satellite navigation since more than 30 years now. And, we, in fact, were pioneers in the introduction of the concept of positioning integrity, which is a capability to detect and exclude in real-time hazards which are affecting the positioning calculation. So we applied this concept widely in the 90s in civil aviation, and we thought, okay, why not? Let's take this and apply it to the automotive market, to autonomous driving in particular. But soon we realized that it was not that easy, and we really needed to adapt the algorithms to the specific context which applies to autonomous driving. Today we are offering, and we have already deployed, a product which is called GMV G#, which is a highly precise and safe positioning for autonomous driving. And I will show it to you now in this video.
Autonomous driving is the biggest revolution for the automotive industry ever. Humans deal with risks daily, but every accident of autonomous vehicles has an enormous impact. So guaranteeing safety is of the utmost importance. For highly accurate vehicle positioning, GNSS with other sensors is needed. But to ensure safety, unexpected errors must be removed. The capability to detect and exclude in real time hazards affecting the positioning data is known as integrity. Protection levels, a trusted area around the position, is provided in real time. And today, we are proud to offer GMV G#, a GNSS-safe, highly accurate and reliable positioning solution, already trusted by the most prestigious global OEMs. Our product is composed of a correction service and an onboard positioning engine that combine to get a trusted position, speed, and heading with outstanding performance. GMV's accurate and safe positioning solution is now on the road.
Okay, that's it. Just to let you know that this product is already in operation with some customers, for example, BMW, in the level 3 function that they offer now in Germany. And it has allowed us to sign some strategic agreements with, for example, u-blox, which is the GNSS receiver provider, one of the most relevant ones worldwide. Okay, to finalize with the ADAS and autonomous driving chapter, just a few comments related in-cabin intelligence. We are familiar with the fact that, there are different regulations and frameworks which are really making the incorporation of solutions or devices for in-cabin monitoring services compulsory on board. And not only this, the technologies that will allow for these driver monitoring systems or occupant monitoring systems can also be used to provide some other features on board related with comfort, for example, or health status monitoring, and so on. And for the purpose, there are different technologies which are a key and enabling that, including, of course, computer vision and artificial intelligence, because, image processing is really essential for gaze tracking, gesture control, emotion recognition, and so on. Then, of course, the sensor fusion algorithms, which are needed for the purpose, and the machine learning and deep learning approaches which are necessary to build the right models which make this IMS robust enough. And all this needs to be managed in the right framework in terms of standards and regulation, both from the safety and from the security perspective. So again, what we did in GMV, in my company, is really leveraging on the expertise that we have developed in other markets, in this case, different space exploration missions, for example, where we had developed expertise in terms of, object identification, human artificial intelligence, human action identification, semantic segmentation, and so on. And we are incorporating that in a product line dealing with the driver monitoring system. So that's it concerning ADAS and autonomous driving. Now, very quickly, a few words about safety critical systems, because as I mentioned before, we are evolving towards higher levels of automation with increasing demands for safety. And it is necessary to really manage safety in an appropriate way at the different stages involved in the deployment of these safety critical systems. So, having done so in other markets, for example, railway or aviation, is not a guarantee of success, but places us in a very good starting point. So when I'm referring to managing safety appropriately, we have to take into account that there are specificities which need to be managed at different levels, including the project management, of course, then the contexts and certification framework. In this case, we would be referring, of course, to functional safety, safety of the intended functionality, PAS 8800, and some others. Then at system layer, it is essential that we are able to manage safety so that we come up with a system which offers the levels of reliability, availability, maintainability, and safety which are necessary. And of course, speaking about software, also considering tools and also the management of safety in the different processes involved in the software engineering activities really needs of the expertise which is allowing us to offer the requirements and the KPIs that we are pursuing. Let's move now to the concept of software-defined vehicle, which at the end of the day is behind all this transformation that we are going through. So, as I said before, this is a new paradigm in which the features and the functionalities of the vehicles are based on software. And this is having an impact on the way the OEMs interact with the different stakeholders in the ecosystem and in the way they operate. So in this sense, technology is gaining momentum. I mean, we are redefining the kind of profiles we have to rely on, because vehicles are not going to be, let's say, a physical product anymore, but they are really transforming into a hardware platform with an operating system. And on top of that, we are deploying different software modules or software elements which configure the vehicle we want to have. And this has got big implications on the activities that they carry out. But at the same time, they are allowing for new business models in the field, because, by the way, offering different features on demand or new subscription to services is really allowing to increase or expand the business that traditionally they have been exploiting. And it is also related with other aspects such as the user or the consumer acceptance, in the sense that the approach is allowing for further upgradings of the software, and this offers kind of flexibility so that it is possible, of course, to correct errors after SOP, but also to redefine the features that we want to enjoy on board. And for the user, this is something allowing them to have a vehicle always up to date and to increase their loyalty to the brand and their satisfaction at the end of the day. So what we have been doing at GMV with respect to this, is coming from, in this case, intelligent transportation systems, where we have been operating for many years as well. And we have been applying this approach, which is focused on centralized architectures in different products that we are offering for our customers, the transport operators, where we are following microservices-based architectures, where We use a hardware platform and a middleware, which is isolating the hardware from the different software elements or software modules that we deploy on top. So, according to the specific situations, we are able to eliminate, to upgrade, to include new modules, and all this is done without having a major impact on the transport service that our customers are offering to the end users, to the passengers. So this is very interesting and is already being incorporated to our activities in automotive as well. And I will finalize with a description of our approach to cybersecurity. So, this autonomous driving adoption and also the progression towards SDV is involving, of course, higher complexity in software. So there is a really huge increase in the number of lines of code that we have to face. They're really increasing demands for connectivity, which involve new attack surfaces to the vehicle, and we have to protect that. And also, we are really progressing towards more centralized architectures. So, cybersecurity had not been taken into account or not so widely in the past because the architectures were providing kind of physical isolation, if you want, but this is not the case anymore. And we have to be capable of offering the right instruments really to make the vehicles robust enough, the cybersecurity mechanisms which allow for this, for data privacy, and so on. So as I mentioned before, one of the areas where we have been operating for years as well is cybersecurity. And, traditionally, we have been offering both proactive and reactive services for our customers, initially in the field or related with the IT architectures and IT infrastructure. So we have done this from our computer security incident response team, which is continuously offering threat intelligence services in order to assess continuously the threats, the vulnerabilities existing, and monitoring them. Sometimes incidents happen, and when this occurs, we assess them, we analyze them, and we propose an action plan in order to recover the previous situation as soon as possible. And once this has occurred, all the information and all the logs that have been collected are analyzed. So there are forensics analysis, post-incident forensics analysis, which allow to get conclusions, to fine-tune the process, and this is carried out in a continuous loop. So what we have been doing since some years till now is really considering also this convergence towards the IT architectures that we are following, really enhancing our SOC to be also a VSOC, a vehicle SOC. And we are providing these kind of services not only for our IT and industrial customers, but also for the vehicle itself and for the automotive customers. So I will finalize with very quick reflections on what I have wanted to share with you today. Nowadays, we are going through a big transformation in automotive market, and at the core of that is the concept of the software-defined vehicle. This has got big implications, but technology is one of the main drivers in this situation. I have wanted to go through some technologies which are essential in this case, including, of course, GNSS, computer vision, artificial intelligence, and I have tried to show you how GMV has leveraged on the expertise on this knowledge in order to bring that to specific automotive products. Thank you very much for your attention. If you have any question, I'm open to that.